Welcome to this physics tutorial. I am Ifeanyi Fortune, and today we'll be looking at dimensions and dimension analysis. So dimensions has to do with the relationship between the basic and fundamental quantities. So let's make this a plural. Basic and fundamental quantities. Fundamental has to do with the relationship between the basic and fundamental quantities. Don't worry, we'll understand that as we proceed. The use of dimensions to derive a formula or prove the correctness of the formula is known as dimension analysis, right? So more specifically, the dimensions of a derived physical quantity is defined as the power of the index. The power of the index, write it somewhere here. The power of the index. The power of the index by which a fundamental quantity must be raised in order to obtain a derived quantity. Don't worry, I will explain this when we take our first problem on dimension analysis. So in dimensions, mass is represented as m. It's what you should know in dimension analysis. Whenever we have mass, we represent it as m, and length as L, time as T. So if you've observed, these are basic quantities, these are fundamental quantities. So all other or most quantities are derived from these three. So for the sake of this tutorial, we're going to deal with derived quantities that are derived from these three basic quantities, and we'll learn how to get the dimensions of these derived quantities from the fundamental quantities. So let us look at these two examples. What are the dimensions of area and work, right? So let's see how we can do that. Let us start with area. Now, the first thing you should always have in mind when trying to get the dimension of a derived quantity is the formula or the derivation of such derived quantity. What do I mean? If you want to, the first step in getting or arriving at the dimension of area is to know the formula of area, right? So if you've not watched a video on physical quantities and units, so I would love it if you watch it before continuing this video, because in that video we had looked at the formula of some derived quantities, and if you have done the assignment, you must have learned others that we didn't include in that video. So if you go back to that video, or if you follow that video very well, you recall that area is gotten by multiplying length. Sorry, this is L actually. It's looking like E. Area is gotten by multiplying length, which is in meters, by another length, which is in meters, right? So having done this is like the first step in resolving a dimension. So the second is you must make sure that the formula is down to fundamental quantities. You must make sure that everything that you're dealing with are all fundamental quantities. Everything, let's say on the right hand side of the equation are fundamental quantities. So for area, both of them are already fundamental quantities. We'll appreciate this particular thing more when we are dealing with work. So let us assume the second step is ticked. The first step was to get the formula ticked. The second step, make sure they are all fundamental quantities ticked. So now the third step is to replace the fundamental quantities or the basic units with their dimension, right? The third step is to replace the basic quantities with their dimension. So if you go back to what we did earlier, we said that the fundamental of mass, we said that in dimension, mass is represented as m, length is represented as L, and time as T. So for area, since area has to do with two lengths, we have to replace those lengths with the dimension of length, and that is L. So coming back here, the third step, replace the length with the dimension of length. Dimension of length is L, right? Capital L multiplied by dimension of length, L. Cool. So we have gotten the third step. So we now say that area is equals to, of course, we know from our basic mathematics that a letter times a letter, let's say A times A is equals to S squared. L times L will be L squared. So this is the dimension of area. So now, what does this mean? So what this means is that the fundamental quantity length must be raised to the power of 2. Must be raised to the power of 2 in order to get the derived quantity area. That is just what it means. So it means that the fundamental quantity length must be raised to the power of 2 to get the derived quantity area. Okay, so let's solve the second example. What is the dimension of work? What is the dimension of work? So if you can recall what I said earlier, that the first step is to know the formula or the derivation of what you are trying to find the dimension. What I mean is that if you're trying to find the dimension of work, you must remember the formula for work itself. How do you derive work? Right? So if you had followed a video on physical quantity and units, or if you have followed a video on physical quantities and units, or you have done your assignments, you realize that work is a product of force and distance. So this is force and this is distance. So this is the formula for work, right? So the next step, so we've done the first step. The next step now is ensure that everything in the right hand side is a basic quantity, right? So let us confirm this. Is distance a basic quantity? Yes. Length, distance and length, the same thing. So distance is a basic quantity. Is force a basic quantity? No. So that means we have to go ahead, break down force, and make sure that we get a basic quantity from force. Right? So let's see how we can do that. You will have to also remember the formula for force. So if you have done your assignment, you realize that force is given as mass times acceleration. So this is mass and this is acceleration. So you ask yourself, is mass mass a basic quantity? No. Acceleration a basic quantity? Oh, mass? Yeah, mass is the derived quantity, sorry. Yes, mass is a derived quantity. Acceleration, is it a basic or derived quantity? It's a derived quantity, so it's not a basic quantity. So we have to further break down acceleration. Remember, the goal is everything in the right hand side should be a basic quantity. So call that acceleration is given as velocity over time. It's actually changing velocity over time. So you ask yourself, time, basic quantity, this is time, and this is velocity. So this is not a fundamental quantity, so no. This is a fundamental quantity. Yes, so we have to see a breakdown velocity. So that's just it, right? You have to make sure that you keep on breaking the derived quantities till you reach a stage in which all what you have in the right hand side is a fundamental quantity. So velocity itself is distance over time, right? It's actually displacement over time, but most times it's used interchangeably. Okay, so distance, yes, it's a fundamental quantity. Time, yes, it's a fundamental quantity. So we have successfully, gotten all fundamental quantities. So what we have to do, we have to replace them back where they ought to be. Okay, let's go back to our first formula since we have gotten all fundamental quantities, so we can give ourselves the next tick. Or maybe we should hold on a bit. Let's hold on a bit. So work is, remember, force times distance, and we say that force itself is mass acceleration, so we'll still keep the distance. So we broke down acceleration further and said acceleration is velocity over time. So our distance is still there, our mass is still there. So we break down velocity further and say that velocity is mass, okay, this will be velocity itself is distance over time, right? So distance still comes in here, right? So mass times distance over time divided by time is distance over time square multiplied by distance, right? So if you are wondering how we got distance over time square, just look at this. So if we say velocity acceleration is distance over time, right? Let us write it in full. Distance over time divided by time. So if you change the sign, if you change the division sign to a multiplication sign, so you remember our board mass, we are conversant with board mass, you know that this will be distance over time multiplied by the inverse of time, right? So when you do this will give you distance over time squared. So that's how we got distance over time squared. So let's go back. We are saying that work is now mass times distance over time squared multiplied by distance. So we've gotten to a stage that we have gotten, okay, we can still say mass distance square over time square. So these are all derived. These are all basic quantities. I'm abbreviating this for quantity. So that means we can give ourselves the second tick. So the next step now is replace the basic quantities with their fundamentals. So do that. What is the fundamental of mass? M. What is the fundamental of distance? L. So when one of the rules of dimension is that when the units are raised to a power, the dimension must also be raised to that power. Okay, what is the dimension of time? T, so raised to the power of 2. So this is the dimension of work. You could also express it as ml square t raised to the power of -2. They both mean the same thing. Okay, so I really hope that we have gotten all this. Remember that you can always pause the video and let's say rewind, and whatever you've not gotten, try to get it very, very well. And if there is anything you are not still cleared, you could always let us know in the comment section. And also remember, you have to watch this video again. You may have to watch it again and again and again to fully understand. So this is your assignment. You have to find the dimensions of acceleration, and dimension of power. Right? Please do it and drop it in the comment section. So don't forget, please, to subscribe. When you subscribe, when a new video is uploaded, you will be notified. Thank you for watching.